Alright, ladies and gentlemen, this is Mark Anderson for Keller Community College, and you made it to the sixth video, the sixth part of the sixth page of our look at the Unit 4 test review for statistics class. Now this last test, this last chi-squared test, as I said in the previous video, these tests have either been goodness of fit tests or preference tests. And since we see some percentages in this, this is a goodness of fit test to test the validity about whether these percentages are on the money. So according to the Bureau of Transportation Statistics, on-time performance by the airlines are the following. 72% are on time, 8 is delayed by the NAS, 9% late, and 12% delayed by the weather. To see if this was true, they recorded 200 flights and found that 125 were on time. 10 were delayed by the NAS, 25 were late, and the rest was delayed by the weather. With an alpha of 5%, test to see if this percentage fits reality. So the null and the alternative, the null is going to say that there is no difference. The percentages are right. So let's just kind of assume that the percentages fit reality. And the alternative hypothesis is going to be saying that the percentages do not fit or match reality. And you can say that in any other kind of way, but the null hypothesis is to say that there is no difference between the percentage and reality, where the alternative is that, yeah, there is a difference. Now, what's important is that we are going to run for, this is our step 1. Step 2, we're going to have, we're going to look at table G. Table G in our book is the chi-squared table. This is going to be right tail, and so what we're going to do is, whoops, T-A-L, we are going to look up the alpha of 0.05 for chi-squared right, and that is going to give us with 3 degrees of freedom. Degrees of freedom is going to be 3, because what we have here is we have 4 categories, 1, 2, 3, 4. So our n minus 1, which gets us our degrees of freedom, is 3. So if I look at 3 degrees of freedom at a right tail test, which are alpha of 0.05 or 5%, is going to get us a critical value of 7.815. Now, for our third step is we need to actually build a table. The table is going to have 3 rows. One row is going to be the category. The second row is going to be our observed, and the third row is going to be the expected. Now, the categories are going to be as following. On time, so I'll put that as OT. Delayed by the NAS, so NAS. Late, so I'll just write out the word late, it's a short word. And delayed by weather, let's just put delayed by weather. Now, the observed value is that we found that there were 125 planes on time, 10 planes were delayed by the NAS, 25 were late, and the rest were delayed by weather. And that would mean that that answer would be 40, because if I add up all these numbers, it would make a total of 160, so the remaining 40 would give us back to the 200. In terms of expected, what I need to do is some calculations, because you'll see that this is a percentage, so 72% were on time. So to find the expected, if we expected these percentages to be spot on, I would take my 200 and multiply it by 0.72. That would give me an answer of 144 if we expected the percentages to be right out of 200. Now the NAS was claimed to have an 8% delay, so this 200 times 0.08, and that 200 times 0.08 would give me 16. So these aren't too far apart, but I still need to run this test to make sure. So this is going to be 200 times 0.09. 200 times 0.09 is going to give me 18. Again, not too much. And this last one here is 200 times 0.12, which gives me the delayed by weather should have been 24, but in fact it was 40. So now I'm going to run my test of the differences between the two, or observed minus expected, quantity squared, in that case it would be negative 19 squared, divided by what we expected, 144. Add that to Observed minus expected, which is -6, and then we square that divided by what we expected, which is 16. Observed minus expected, which is going to be 7, and then that's quantity squared divided by 18. Observed minus expected, that's 16, quantity squared divided by 24. If I add all of these up, I get an answer of 18.15. Now that means that for step 4, my normal curve, since I'm going to try to fit this all on one screen here, I'm going to have chi-squared non-normal curve, excuse me, I said normal, but this is a skewed right curve with a critical value at 7.815, and there's my shaded region, and we plant it all the way over here with our test value of 18.15. So step 5, we reject the null hypothesis because, B/C, because 7 and 815 thousandths is less than 18 and 15 hundredths. So we definitely see that the percentages are to be moved, because when our sample of 200 flights, we had a lot of difference. It shouldn't have been this far off in each of these categories right here. And since we were far off in each category, it's time to recalibrate, because these percentages do not fit reality. All right, well, thank you if you've been through the other 5 and this is your last video. Congratulations, you made it, and thank you for watching. I appreciate every click and view.